Hello everyone, and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook, and I'll be assisting with today's demonstration on density and its application to fluids, more importantly with buoyancy. So the first thing that we're going to talk about is the definition of density. So as you see on the board on over there is that we have the Greek letter rho is equal to mass over volume, which is denoted as m over v. Remember, the Greek letter rho is going to stand for density. So normally in SI units or in System International units, it's going to be kilograms per meter cubed. But another unit that will go with CGS is going to be gram per centimeter cubed, not squared. So the density of water is equal to 1 gram per centimeter cubed. And today's little demonstration is that we're looking at 6 what appears to be looking identical rods that have the same volume, which on the board behind me, I calculated that volume by going, this is a cylinder. So it has a circle that I need to find out what the area of that circle is, and times it by the height or the length of that cylinder. So my volume is equal to pi r squared, which is just the area of a circle, times h, which that's about 93.3 cubic centimeters. So for these objects to float in this sense, I need to have the density of these objects be less than 1 or equal to 1, because the density of water is 1 gram per centimeter cubed. So that means that the minimum that these items have to weigh for them to float has to be 93.3 grams or less. So if they all look identical, I should be able to tell whether or not they kind of seem they are very dense or not in terms of how much material they have inside by just hitting them on this little table. So if I did this with this one, sounds like it's got good strength to it. Might be really heavy. Let's try this guy. Kind of sounds very similar. Let's try this one. Oh, it's not producing a lot of sound. Maybe it doesn't have as much mass. Might be pretty light. I'm going to put this one over on this side. We got another one. This one kind of sounds like it's an in-between. Like maybe it's a maybe maybe not light, maybe not heavy. This one could be an abnormality one. This one seems really heavy. And this one feels, given that same sound, that really deep sound, is that these guys might be really, really heavy. And these guys might be really light. So let's see if we can zoom in a little bit more and see if we can see which one of these float and which one of these sink. Well, now let's take a closer look at whether or not these objects will float or sink, which is based on the density of them. So now we have our 4 objects that we thought were really heavy, or 1 object that we thought this could float, this could sink, and 1 that we thought, you know what, this sounds like it might be very light or have not as much mass. We might think that one will float. So let's try our first one. Big splash, as you can see, sinks right down to the bottom. I'll put this one over here. Try our next one. Big splash, again sinks. Third one. Again, sinks down to the bottom. No, with a big splash. Fourth one. Sinks down to the bottom. Now let's try our mystery one. Let's see if this one sinks or floats, because remember, this almost sounds metallic, but it could potentially float. So let's put it in the water. Sinks down to the bottom. So all that means that all 5 of these have a density of greater than 1 gram per centimeter cubed. So now with this one, let's give it a quick test. I'm going to drop it from here. You saw that it hit the bottom, but it went right back up. And it's now floating on the surface. That just tells me that even if I held it really close to the surface, or really far away, because of its density, it floated right back to the top. Well, thank you for watching this video presentation, and have a wonderful day.